Alright, in this video I'm going to be working Multivariable Calculus Quiz 2.4 again. We're going to be doing some tangent planes and normal lines, and unfortunately I've made this key twice and I can't find it. I guess I deleted it or didn't press save both times, so let's just do it now. So first, write an equation for the plane tangent to the surface defined by g of x and y is x to the 3 minus y to the 3 at the point here. Okay, well we're going to need our partials, so gx equals 3x squared. Gy is going to equal negative 3y squared. Okay, at the point gx of 2 and negative 1, that's just going to be 3 times 4 is 12. Gy at the point where x is 2 and y is negative 1 is going to be negative 3 times positive 1. And so I'll have z minus 9 equals 12 times x minus 2 minus 3 times y minus negative 1. Then we'll find the coordinates of all the points where the tangent plane is horizontal. Okay, now if we see that, that means that both the x derivative and the y derivative need to simultaneously equal 0. All right, so we're going to have to take that derivative implicitly here. All right, so with respect to x, I'm going to have 2x plus 0 minus 2 plus, okay, the derivative of z squared, we have to assume z depends on x, so that'll be 2z partial derivative of z with respect to x, because of the chain rule, and that'll equal the derivative of 1, which is going to be 0. If I, kind of collect this all around, the partial of z with respect to x is going to be 2x minus 2 all divided by 2z, or negative 2z, yeah. And then if I kind of go the same process with respect to y, okay, the derivative of x squared would be 0, derivative of y squared is 2y. Derivative of negative 2x will be 0, so I'll have 2y plus 6, and then plus a 2z partial derivative of z with respect to y for the chain rule. Okay, now if I collect it all around, I'll get partial derivative of z with respect to y is going to equal 2y plus 6 divided by 2z, negative 2z, yeah. Okay. Now, if I want them both to equal 0, that's going to mean that the numerators of both have to equal 0. I need this top to equal 0 and this top to equal 0 at the same time while the denominator is not equaling 0. Okay, so basically if we just find these points and we make sure that z is not 0, we should be good to go. Okay, 2x minus 2 equals 0 when x equals 2. And 2y plus 6 equals 0 when y is negative 3. And those two things could happen at the same time. X equals 2, y equals negative 3. What I'm going to do now is I'm going to plug those values into the original equation and hopefully find z. So x squared is 4 plus y squared is 9 minus 2x is minus 4 plus 6 times negative 3 is minus 18, plus z squared equals 1. All right, so 4 minus 4 is 0. 9 minus 18 is negative 9. And so I'm sitting with negative 9. I add that over and I get z squared equals 10. And then that means z is either the positive or negative square root of 10. Okay, so my points are going to be x is 2, y is negative 3, z is equal to the square root of 10. And then I also have x is 2, y is negative 3, z is the negative square root of 10. But this should make a lot of sense because this graph here is a sphere that's not centered at the origin. But we know that, a sphere is going to have a horizontal tangent plane. I don't even know how to draw that, obviously with parallelogram. About like there at the very top. And then also at the very bottom. That's going to be a horizontal tangent plane as well. Okay, the one on bottom looked a lot more horizontal than the one on top. Let me see if I can make that better. Alright, that still didn't look that great, but you get the point. Okay, there's 2 points that have a horizontal tangent on a sphere, and they sit directly above each other. Okay, and so they would have, and when it's at least centered where z equals 0, so we would expect plus or minus the same number. Alright, write an equation for the normal line to the graph. Okay, we're going to need the partial derivatives. So fx equals 3x squared y. fy equals x to the 3. So at these points, I'm going to get 3x squared y is 3 times 4 times negative 1. Fy is going to equal x to the 3. Okay? And so our formula is going to be that the line is equal to, okay, the x component is the x coordinate plus fx times t, so negative 12t. Then y is negative 1 plus 8t. And then we need a z coordinate, so z equals f of 2 and negative 1, which is going to be 8 times negative 1 is negative 8. So negative 8 minus t. And number 4. Now this one was ungraded, but only because I hadn't this year when I first written this quiz, I had not, what am I saying here? I just hadn't shown him how to do this. Okay, this is not a hard question. It's definitely still on the multiple choice test, but we just didn't score this one. So I've got fx, fy, fz, and then at the point 3, 4, 5, it really is as easy as you think it might be. 7 times x minus 3 plus 8 times y minus 4 plus 9 times z minus 5. That's going to equal 0. Okay. And if you're a little unsure of like why that works or whatever, I would just encourage you to come talk to me about it. I can convince you of that. So the figure below shows a contour map for the function f of x and y. And this is something that I had meant to put on the previous quiz, but it just didn't make it on there, so I just threw it on here. But I think we could do a little bit better. I could have like had you estimate the tangent plane or the normal line or something using these estimated derivatives, but that's okay. Okay, partial derivative of f with respect to x at the point 4 and 1 is going to be approximately equal to change in f divided by change in x. So at the point where I've got x is 4 and y is 1, I measure how far do I have to go to get to the next grid intersection point. Okay. When delta x is 3, and then delta f is, okay, I went from level 11 to level 14. That's also an increase of 3, and so that's 1. If I'm trying to estimate the value of df dy, okay, I could use either of these. I didn't notice that there was a point down below, but I'm just going to use the one that's above. So partial derivative of f with respect to y at the place where x is 4 and y is 1. Okay, that's approximately equal to change in f divided by change in y. Okay, now, change in y was 2, and then the change in f going from level 11 back to level 8 would be a change of negative 3. And that was form P. Now, in form Q, we're going to do a little bit more of the same. We're going to do some derivative estimating from a contour map. And so if I want to estimate fx at the point 4, 1, I'm going to go over here. Let's see, all right, went right by 3. So x increased by 3, and f decreased by 4. Okay. And really what I was doing here was I was estimating the partial derivative of f with respect to x at the point 4, 1, using change in f divided by change in x, which was equal to that number. If I wanted to estimate fy, I'd be thinking about, okay, what was the change in f when I went from one contour line to another? So I went from level 7 to a level 11, that's positive 4, divided by change in y was positive 2. So let's say that was change in f divided by change in y, which is approximately equal to the partial derivative of f with respect to y. Right. Now, if we want to write an equation for the tangent to this surface, okay, we're going to take our partial derivatives, get our point, get our partials, write our equation. So gx will equal 4x to the 3. Gy will equal negative 4y to the 3. Okay, at the point where x is 2 and y equals negative 1, 4 times 8 is 32. Negative 4 times negative 1 to the third would be positive 4. So I've got my partials, I got my point. It's going to be z minus 15 equals partial derivative with respect to x times x minus the x coordinate. plus the partial derivative with respect to y, yeah, that is positive 4, times y minus negative 1. Okay. Now for number 4, if we want a horizontal tangent plane, we need both of the partial derivatives to simultaneously equal 0. So we're going to need to take both of the partial derivatives. But this thing is kind of defined implicitly. So that means I'm going to have to take the derivative implicitly. So I'm going to find the derivative with respect to x first. I'll say that's 2x plus 0 minus 6 plus 0, and then the derivative of z squared is going to be 2z times the partial derivative of z with respect to x, because z is really just f of x and y, or at least we're assuming that right now. And that's going to equal the derivative of 1, which is 0. So if I wanted to, solve for partial derivative of z with respect to x, I would be getting 2x minus 6 all divided by negative 2z. And I'll repeat the process for y. I'll say, all right, for y, I'm going to have 2y plus 4 plus 2z partial derivative of z with respect to y. And that's going to equal 0 altogether. And so if I was to solve for the partial derivative of z with respect to y, I would get 2y plus 4 all divided by negative 2z. Now, if I want a horizontal tangent plane, I need both of these fractions to equal 0. So that means their numerators have to equal 0. That would happen when x was equal to 3 and when y was equal to negative 2. Now, that would be true as long as z is not 0. But what we're going to do, we're going to plug in x equals 3 and y equals negative 2 into this equation, and we're going to see that z will not be 0 on the point on the graph that satisfies that. So, plugging into the original equation right here. Okay, x squared, that's 9, plus y squared, that's going to be 4, minus 6x, plus 4y, plus z squared, equaling 1. All right, 13 minus 18 is negative 5 minus, wait a second, I don't remember getting that number. Double check that. X squared plus y squared, 3 plus 4. Okay. Oh, maybe I'll just look at it differently. Negative 26 plus 13 is negative 13. If I add that over, I'm going to get z squared equals 14. I think at this point I don't even remember what I got the other times I worked this quiz. And so that means z equals plus or minus the square root of 14. So my points of horizontal tangents here, x equals 3, y equals negative 2, z equals square root of 14. And also x equals 3, y equals negative 2, z equals the negative square root of 14. Right, now if we want the normal line, I thought about this after I did the one on the other form. I should have just written out the general formula. So L of t is going to be, okay, it's the x-coordinate, y-coordinate, and z-coordinate. Okay, well, I'll need to figure out the z-coordinate. Z is going to be f of negative 1 and 2, which is going to be negative 1 to the 4th times 2, that's going to be 2. Okay, so then I'm going to need my partial derivatives, because I'm going to have partial derivative with respect to x, partial derivative with respect to y, and then just minus t. All right, so over here, I need my partials. So fx is going to be 4x to the 3, y to the 1. And fy is going to be x to the 4. If I plug in x equals negative 1 and y equals 2, I'm going to get negative 8 there, and I'm going to get positive 1. All right, so fx is negative 8, so that means I'll need minus 8t here. Fy is 1, so it'll be 2 plus t. And then I've got myself an equation for a normal line. Remember, a normal line, especially for a z equals f of x and y, it needs to be a line in three-dimensional space. We saw a lot of responses that were only giving 2 components on their vector. And I think that's just because I didn't give you z equals 2 on this one. But, just because I don't give it to you doesn't mean you aren't expected to find it. So that's something you need to do. All right, now the last one here, number 6. Yeah, this one was ungraded, but it doesn't mean I took it off the test. It's just like this particular year, I hadn't prepped y'all for it, and I forgot it was on there. So what we're going to do here is it's fx times x minus the x coordinate plus fy times y minus the y coordinate plus fz times z minus the z coordinate. And that's going to equal 0. And that's all for this video. Thanks for watching.